Okay, in this video, we're going to be looking at combining functions through the operations of addition, subtraction, multiplication, and also finding quotients. We're going to be asked to give the most simplified version of the answer possible, and we're also going to be asked to find the domain for each of these combinations. The domain, let's just talk about that a little bit before we begin. When you combine two functions, you're really going to consider the domain of each of the original functions. That's what this means, domain of f, domain of g. And you're going to analyze what they have in common in order to find the domain of the combinations that you're about to create. So why don't we first start off by graphing the domain of f and the domain of g and seeing what they have in common. This is pretty easy to do when you graph the domain for each of the individual functions on a number line and then just look at where they overlap. So the domain of f, being that this is just a polynomial, it's not a fraction, so there's nothing that can make the denominator 0, and it's also not a radical that needs to be protected. So you can actually use any real number in the function f. So I'm going to shade all the numbers that x can be in the function f. And I'll just kind of put it in this pink color. Okay, so all real numbers from negative infinity to positive infinity. Then if we look at the g function, we see that it's the same type of function. It's also a polynomial with no restrictions. So it is also all real numbers from negative infinity to infinity. And just discussed that when you're doing combined functions, when you're combining two functions, we want to look at what elements do these two domains have in common, and that would be everything. All the numbers that are in the domain of f are also in the domain of g. Okay, so the combined domain is going to be, for this particular these particular combinations, negative infinity to infinity, because that's where they overlap, unless as we do the combination, we impose some new element to the function. Like, for instance, in doing the combination, maybe we create a fraction. Maybe we create a radical, although that's not possible because we don't have radicals here. But notice that in the fourth part of this problem, excuse me, we are going to be doing a quotient. So we are going to have a fraction. So then there will be some new restrictions imposed. But in general, the domain for the combinations that we're going to be creating in parts 1, 2, and 3 will be negative infinity to infinity. Because in performing any of those three combinations, you don't create fractions or radicals. So we stick to that, that domain from negative infinity to infinity. So let's do the first part, where we're doing a sum. And we are taking 6x plus 10 and adding x minus 3. 6x plus 1x, and all you're doing is combining like terms in order to give the most simplified version of the answer, would be 7x, 6x and 1x, and then 10 take away 3, 7. So the sum, we have combined functions f and g through the operation of addition, and the sum is 7x plus 7. The domain, negative infinity to infinity. Okay, then the next part, we're going to be finding the difference. So we're combining f and g through the operation of subtraction. Function f, once again, is 6x plus 10, and we are subtracting the g function. You might want to put the entire function in parentheses just so you remember to apply this negative to both terms. So as we combine 6x plus 10 with the g function, we'll be paying attention to these switched signs, and that always happens when you're subtracting. So 6x take away 1x, that's 5x, and then 10 plus 3 is going to be 13. So the most simplified version of this combination through subtraction that we can give is 5x plus 13. Again, notice these answers are not introducing any new element that would impose a restriction, such as a fraction. So that's why we are sticking to what we found out to be the overlap, which is all numbers from negative infinity to infinity with respect to the domains of the original functions. Moving to the third part. In the third part, we're going to be finding a product, and that's what it means to have f times g. They can put a dot in between them. You can put parentheses around them. There's different ways to indicate that you're going to find a product, or you can just put those right up against each other. So we're going to be multiplying the polynomial 6x plus 10 times x minus 3, and you know that's foiling. You're going to multiply that 6x times the x as well as the negative 3. Likewise, you're going to multiply the 10 by x as well as the negative 3. So this is going to give us, following these arrows at the top, I'll do the short one then the long one, 6x squared, because we're adding those powers. Then 6x times negative 3 is going to be negative 18x. And then the two bottom products would be 10 times x, 10x, and then 10 times negative 3 is going to give us negative 30. Then combining like terms, we have a squared term. When we combine these two linear terms, we have negative 8x. And then bring down the negative 30 for our constant. And that represents the product. Okay, moving on to and again, the domain is not going to change. It's still negative infinity to infinity. Next, we're going to do the quotient as the last part of the problem. So we're doing f divided by g. That gives us 6x plus 10 on the top, x minus 3 on the bottom. Now to simplify these things, you would try to factor, but all that you can do in the top is take out a 2. 2 is common to both of these. And if you did factor out the 2, you would just be left with 2 times 3x plus 5, and that doesn't help you cancel anything in the bottom. So this actually is, oops, and I guess I'm not really showing you that. So again, even if you were to try this to factor it, you would have 3x plus 5. That does not really help you cancel anything in the bottom. So therefore, you might as well leave it just like this. Okay, but I just thought I'd show you that. Sometimes you try to factor because factoring is the way you simplify polynomials that are in quotient form. But nothing became of that, so we leave the quotient the way it is. So this is the answer to the quotient. And then as far as the domain turns out, it does happen that we've created a situation that we need to protect. We now have this new function. It is now a fraction, and anything that makes the denominator 0 is going to make this entire combined function undefined. So we have to protect that situation. So when we look at combining the domains of both of the functions, here's our little number line. Again, you know that the domain for f is all real numbers. So all of this represents the domain for f. And then the g function is all real numbers except for 3. So that would be everything up to 3, but not 3. So when we look at the domain for those two functions, it's everything to the left of 3, everything to the right of 3. So the overlap would be all of this, everything to the left of 3, everything to the right of 3. And that is stated like this: negative infinity up to 3, not including 3, or anything to the right of 3 would be 3 to positive infinity. All right, and that completes the domain.